to review for honors pre-calculus. So here we go. Cotangent of 180. So if you're thinking about on your unit circle, 180 will be right here. And so that's the point -1, 0. And the cotangent will be the cosine, so the x over the y, and therefore we will have a -1 over 0, which we cannot have. This is undefined. For number 2, we want the cosine of 21 pi over 6. So first we have to think about, okay, this is more than one rotation of the circle, so we have to wonder where would that correspond in just one rotation. So just simplify this fraction. So cosine of, so we're going to divide by 3 will be 7 pi, divide by 3 will be 2. So we had 7 pi over 2. And 7 pi over 2 will be the same thing. So if you're thinking about your unit circle again, right? So you'll have 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So you will be down there, right? So 7 pi over 2, the cosine of 7 pi over 2 will be 0. Sine of -510. So here we want to think about the sine as being an odd function. And because it's an odd function, we know we can take that negative on the outside. That will be the same thing as negative sine of 510 degrees. And then 510 degrees, if you're subtracting 360, that will be the same thing as negative sine of 150 degrees. And 150 will be right there. And so the sign there will be 1/2. And because we want a negative, this will be equal to -1/2. Then we have the secant of 4 pi over 3. And so we have to remember that secant is the same thing as 1 over cosine, right? It's the reciprocal of cosine. So the cosine of 4 pi over 3 is what we're looking for. And then we take its reciprocal. And the cosine of 4 pi over 3 will be right there, right? Do I have that right? 1, 2, 3. No, right there. Sorry, that will be right there. Right here. And so this will be on the negative side of the cosine, right? So a -1/2 right there for the cosine portion of it. And so that will be 1 over a -1/2, which when you do multiply by the multiplicative inverse will give you a -2. All right. Tangent of 7 pi over 4. So you will have to know this is just going to be equal to 1. Right? If you're thinking about the unit circle, 7 pi over 4 will be right there. And the tangent will be positive times, excuse me. So this will be 1 pi over 4, 2, 3, 4, 5, 6, 7. Yeah, I'm on the right spot, but this is not correct, right? Excuse me, this should be a -1/2. My apology. All right, then I have secant of 140 degrees multiplied by a cosine of 140 degrees. So the secant of 140 will be equal to 1 over, secant is the reciprocal of cosine, times the cosine of 140 degrees. And when you write it this way, you can see that those two will cancel, that probably goes to a 1. And same here, we have a cotangent of pi over 7. Well, the cotangent we know is cosine over sine. So if we do cosine over sine minus cosine over sine, that will be equal to 0. And here we have sine of -pi over 8. So we have to reconcile that this is an odd function. Therefore, this is the same thing as negative sine sorry, that's not 7, that's pi over 8. And then we have a cosecant of 17 pi over 8, which is really just the same as a cosecant of pi over 8. Right, because 16 pi over 8 will be 2 pi, that's 2 full revolution. Sorry, 1 full revolution plus 1 extra, right? So that would be the 17 pi over 8 right there. And so the cosecant, we have to remember that this is the same thing as the reciprocal, so it's multiplied by 1 over sine of pi over 8. And therefore those two cancel, that's just going to be equal to 1, but we have that negative in the front there, so that's a negative. All right, that's for the unit circle. Now let's look at some equations. So we have to write the equation no phase shift here. So we just want to look at what we have, and we're going to write it as a sine then, obviously, because we're starting on the midline at the origin there, and we're going to choose the maximum first, and the maximum happens to be at 3, and the minimum happens to be at negative 3. Therefore, the midline is y equals 0. And the amplitude is 3. There is no reflection, and then we have to check for the period. So it looks like from here to here is 1 full cycle, right? I reached my maximum, my minimum, and I'm back to where I started. And so the period here looks like it is pi. So if the period is pi, and we know that normally it should be 2 pi for a sine function. So 2 pi divided by b, what will b have to be? Therefore, b would have to be equal to 2. And so the equation would be y is equal to, so amplitude we said it's 3, so 3, and it's a sine function. And if we use, we can use x or theta. Let's use theta here to be fancy, or to be more like trigonometric notation. So this will be a b of 2, so I need a 2 theta. Okay. So here it looks like on the y-axis we're going to reach a maximum first. So this looks like it's a cosine function, right? If I don't want a phase shift. And the midline will be right here. And this will be negative 2. So midline is at y equals negative 2. Oh, it is not easy to write on that screen. I apologize for that nasty handwriting. Midline is y is equal to negative 2. Let's look at, so the amplitude, it looks like we just go up by 1 and down by 1, right? So amplitude will just be a 1. There is no reflection because on the y-axis we are on the maximum. And now let's look for the period. So here to here is 1 full cycle, right? I went down to my minimum, came back to the maximum, that's 1 cycle, and it looks like it's over 2 pi, therefore that's the regular period. So that would just be a b value of 1. So then I'll have, and again, if I call this my theta axis, then I would have y is equal to, amplitude we said is 1, there is no reflection, and we said this is a cosine function of theta, and we just go down by 2. All right. Okay, so here it looks like, so we are not going through the origin, we're here at pi over 2, and the period looks like it's from 0 to pi, and therefore this looks like it's a cotangent. The midline, we haven't shifted up or down, is at y equals 0. And period is pi, so this is regular period for a cotangent or a tangent, right? So we're good there. And the cotangent starts, is a decreasing function on all its domain, right? So this one is definitely decreasing everywhere, right? So there is no reflection, and so this is just the plain old y is equal to the cotangent of theta, the parent function. Okay, so here this looks like it's a tangent, right? Because now I'm going through the origin, and remember we don't want a phase shift. This function is decreasing though, so if this is a tangent, but it is decreasing, then that means I have a reflection. So I need a negative in the front. And then for the period, I'm going from this asymptote to this one. What is that? So if pi is here, it looks like this will be pi over 2. Therefore, that's pi over 4. And this is negative pi over 4. So the period pi over 4, from negative pi over 4 to pi over 4, the period will be pi over 2. And so if the period is pi over 2, what would the b value be? Well, tangent, cotangent have a period of pi normally. So b will be equal to 2. Okay, so we said reflection, right? So we need a negative, and we said this is a tangent. So y is equal to negative. Oh, I didn't check for, looks like we go, it doesn't look like we have a stretch, right? So we're going to go negative tangent, and we said b is 2, so 2 theta. All right. Now we're going to write the first one as a sine. Oops, I didn't mean to move you. Are you back on my paper? I moved this a little bit and I want to move it back where it belongs. Okay. All right, so we need to write a sine function for this one. So we want a sine here. And so normally the sine starts at the origin, but this one does not. This one starts right here. So we have to wonder what that is. Now watch the scale. From here to here, that's a 2. Therefore, halfway through, that's a 1. So this right there will be 1/2. Okay, so it looks like we have a phase shift by 1/2 to the right. Okay, then there is no reflection then, because then we are going up toward the maximum from the beginning point if we do a phase shift of 1/2. So no reflection there. Now we look at the period. So from here to there, what would the period be? So from 1/2 to this will then be 4.5, right? So we have a period of 4. And if we have a period of 4, then that means that 4 is equal to 2 pi over b, and therefore b will be equal to pi over 2. Okay, so we're going to, I think we have all we need. Oh, no, I missed something, don't I? An amplitude. We have an amplitude of 2. So now I think I'm ready. So y is equal to 2 for the amplitude, and we said that's a sine function. So sine of, we have a shift of 1/2 to the right and a period of 4 with a b value of pi over 2. So pi over 2 x minus that shift, and then no shift up or down because we don't have a midline other than 0. Notice the extra set of parentheses. This is very critical that you notice that. So we have this extra set here. So we're kind of putting alone or factoring out that b value, right? So that it doesn't affect our phase shift. Because if we would rewrite that without that extra set of parentheses, this will become y is equal to 2 sine pi over 2x minus, and then that would then become pi over 4. And those two are equivalent, right? Because that would just mean I distributed this pi over 2 there. So you have to be careful. If you don't want to distribute this pi over 2 b value, then you need that extra set of parentheses. All right, next one. Here we need a cosine function. So if I want a cosine function, I know I need to start on the maximum. And so I could use this point right there or this point right there. Usually we take the closest one to the y-axis. So this is at -6, right? And this one will be at 10. So I'm going to go with -6 because it will be closer to the y-axis. But you could pick 10 and that would be just as fine. So I'm going to say phase shift of, let's not write off. The phase shift is, so I'm going to say 6 to left, because that's what I'm using, -6. And then I look, so up here, now we have to pay attention to the scale. I'm at 5 up here, so 1, 2, 3, 4, 5. Looks like each little square stands for 1 unit. And so I'm at 3 here, and down here I'm at 1, 2, -3. Therefore, it looks like we have an amplitude of 3. And if I phase shift to -6, then I would start by decreasing, therefore I wouldn't need a reflection. So I'm good there. And what else am I needing? I have the amplitude, the midline will be 0, right? Y equals 0, because we're 3 above, 3 below. And what would the period be? So if I start at -6 and I go all the way to 10 here for one full cycle, from -6 to 10, I would have a period, looks like, of 16, right? So 16 is equal to 2 pi over b, and therefore b is equal to pi over 8. Okay, I think we have everything we need, so let's write it. So we're going to have y is equal to, no reflection, but an amplitude of 3. We're using a cosine function. We're going to have a phase shift of 6 to the left and a b value of pi over 8. So pi over 8, separate the b value from the variable with the phase shift. So x minus, actually I want a plus 6 because I'm going left. And then we said no midline, so that should work. And again, if you want to distribute this pi over 8, you are welcome to do that, right? And you could also have used that 10 here for your phase shift, in which case here you would have a -10 instead, okay? All right, that's for this one. Okay, now let's go to graphing equations from given graphs. Okay, and we're told that we need to graph 2 periods for each one of them, right? And we need to write the domain and the range. Okay, so let's just analyze the equation first, the function given to us. So I'm already noticing that it is a sine function. So I know sine function goes like that, right? And I want an amplitude of 4. I have a midline that is y equals 3. Okay, so if I have an amplitude of 4 and a midline at y equals 3, then I need to figure out what is my max value and what is my mean value. Well, my maximum will be my midline plus the amplitude. So the maximum is going to be at 7. And the minimum will be the midline minus the amplitude. So 3 minus 4 will be at -1. Well, that already gives me my range, right? So my range is going to be from -1 to 7. And by the way, the domain we already know, because domain of sine function is all real numbers. So we know that. Okay. Okay, so now I need to worry about that b value of 3, right? So if I have a b value of 3 and I know that the period is equal to 2 pi over b, which is 3 here, then the period will be 2 pi over 3. Okay, so accordingly, I have to break my scale on my x-axis. Okay, I need to go all the way to 7, so probably already did that wrong. Let's try to do that. I just go -1 down here, but then here I need to go to 7. So 1, 2, 3, 4, 5, 6, 7, and -1 down here. Okay, the midline is at 3, so right there. Okay, and I usually like to do a little, so I know not to pass that and not to pass that. Here we go, for the min and the max. So I know my function is going to be graphed between those two extreme lines, right? And now the period is 2 pi over 3. So I'm starting with the sign, so I'm starting on the midline. And then one full period will be 2 pi over 3. So I'm just going to place that and say, okay, this right there will be my 2 pi over 3. Okay. So then I divide that into 4 sections. And so that will be pi over 3, right? And so I'm going to be on the midline halfway through again, because this is a sine function. And then I'm starting by reaching my maximum halfway through those and the minimum halfway through those. So this should look like that. This is for 1, and then I need to do 2 of them. So usually we go 1 in the positive direction, 1 in the negative. So again, I'm going to go, that looks like the same distance will be about here. So this here will be -2 pi over 3. Halfway through will be -pi over 3. And so I will be on my midline again. I'm going to reach my min halfway through, my max halfway through here, and it looks like we're going to come like that. Here we go. Put an arrow at the end, and good enough. All right. Number 2, negative tangent of x minus pi over 2. And I'm going to change color just so that our graphs and work doesn't run into each other and we get confused. So let's go purple. Okay. First of all, I notice I have a tangent, so I need to think about what does the parent function of a tangent look like, and it looks like that, right? And then repeated from that, and that will be at -pi over 2 and pi over 2, and the period for the parent function will be pi. All right, so I have a negative here, so I know already I need a reflection. So instead of increasing everywhere, my function is going to have to decrease. And then I have a phase shift, pi over 2 to the right. And that's all I have, right? The period hasn't changed, so the period is going to stay pi as the parent function. And we don't have any vertical stretch and no midline change. So let's grab that. So we're going to go so we have a phase shift of pi over 2, and at pi over 2, so normally I'm going through the origin here and I'm shifting that to pi over 2. So wherever that's going to be pi over 2 here, I'm now going to be crossing right there, and right here my y-axis becomes a vertical asymptote, and I have another vertical asymptote right here at pi, right? So this is at 0, this is at pi. And then let's do another one at negative pi because we need 2 periods. Okay. So I'm going to go through here as well. And we said that the tangent function is normally an increasing function, but because of that reflection, we're going to be decreasing. So my graph is going to look like that. Okay. All right. We're going to go to a second. All right, interesting. Let's go green, go Irish. All right, so the second, we want to think secant of an angle is equal to 1 over the cosine. So the base function we want is going to be a cosine function. And therefore, our secant is going to be as such, right? So we need to be thinking about that. Woo, we have a little bit of work to do because notice how the b value and the phase shift, the b value has been distributed. So we need to factor it out first. So we have a y is equal to 3 secant pi over 3 x plus, and if I divide 2 pi over 3 by pi over 3, I just get a 2. Well, that's kind of nice. So period for a secant is the same as the one for a cosine. So technically it was 2 pi, and then we divide by the b value, and my b value is pi over 3. So therefore the period is going to become 6. So I need and I have an amplitude. Let's notice that too, so I know how long to make my axis here. Amplitude is 3, and the midline is at 0, so that's not changing, but that means that okay, period is 6, and I have a phase shift of 2, so I'm going to say if I go 6 here, that will be 1 full period, but I have a phase shift 2 to the left. So really we're going to start right there at -2. So let's do the cosine in a different color. Let's do kind of a light yellow. So normally the cosine will start on its maximum and it would end at its maximum again, right? So 6 away from -2 will be at 4. And then halfway through will be at 1. I will be at the minimum, right? And so my cosine which is really not what I want to graph, so I'm just going to dash it, would look like that. Okay, so what I want, I need a few more. I need 2 periods, so I need to go further, either left or right. I want to go further right, left, so -2, 3, 4, 5, 6, 7, 8. That should be enough, right? Because period is 6. From -2 to -8, I have 6 units. So that means that I will be back up here, and then halfway through, we will be at the minimum. Okay, so it should look like that. Okay, and why do I want that? Because now it's nice and easy to graph the graph we actually want. The asymptotes are going to be, let's put those in a different color as well. The asymptotes are going to be wherever the cosine is 0, right? Because the secant is 1 over a cosine, so wherever the cosine is 0, we're going to have an undefined value. So all of those values are going to be, oh, that should be, ooh. Actually, that should be not quite on the y-axis. It should be kind of like there and then there. Okay, now let's see if we can graph it. So it will be like so. Etc. Okay? All right. I want to make sure that this line right there is not misinterpreted being at the wrong spot. This should really be going through -1/2 here. Right, okay. So this is coming all the way to there. Okay, all right. Let's go orange, let's go gold for the number 4. Okay, we have an amplitude of 2. This is a cosecant, and a cosecant, oh, sorry, I said cosecant and I wrote cosine. Cosecant of theta is actually 1 over the sine. So we know our graph is going to be related to the sine graph, right? Okay. And there is a b value of 1/4. So the period is normally pi, and so pi divided by 1 over 4 will give me a period of 4 pi. And so sorry. My mistake. I mean, I'm not with a sine here. The period of a sine, sorry, so the period of sine is 2 pi, right? And so I have a b value of 1/4, and so that will definitely be 8 pi. So that will be a different period, right? Right, gee, I'm glad I caught that. So 8 pi, and then what else do we have? We don't have a phase shift, but then there is a midline of -2. Okay, so if I have a midline of -2 and an amplitude of 2, let's find the max. So the max will be the midline plus the amplitude, so max is at y equals 0, and the mean will be the midline -2 minus the amplitude, so the minimum will be at -4. Okay. So, oh, I need a period of 8 pi, so okay. Actually, I don't need that much room below because the minimum is 0, the maximum is 0, right? So let's put that up here. Okay, so here is my midline. the max is going to be at 0 right there. And the minimum is going to be at -4. The base function is sine, and then I'm going to use the base of a sine to build my cosecant. I don't have a phase shift, but the period is 8 pi. So normally the sine, let's switch color here again. So normally the sine starts on the midline. And let's do 8 pi here. Therefore, that's 4 pi, 2 pi, 6 pi. Let's see what happens here. So we're at 2 and we end at 8 pi, and halfway through we're going to be on the midline again, and then the sine goes to a max first, then a min. So the base looks like that. And if I extend it, all right, it looks like we're ready. Oh, let's do the asymptotes as well. Okay, so the asymptotes are wherever my sine is going to be 0, so that will be right there at -8. It will be at -4 pi. It will be at 0, at 4 pi, 8 pi, etc., etc., etc. And so the graph would look like that. Etc. We have 2 of them. We're good to go. All right. One to go. Okay, this is a cotangent. We have an amplitude, so if it's a cotangent, my parent function would look like that. And that will go from 0 to pi, right? With intersect the x-axis at pi over 2. And we have an amplitude of 2. So we're going to stretch that a little bit. A cotangent is an odd function, so that negative there can be brought to the outside. So that's the same thing as saying -2 cotangent pi x. Therefore, we have a reflection. So the function, instead of being decreasing like my parent function, is going to be increasing. We have a b value of pi, and so the period is going to be, normally it's pi over b, and because we have a period of pi here, we have a b value, sorry, of pi, then the period just becomes a 1. Well, hopefully that makes it easy to graph, right? So let's try that. So we're going to say we have a period of 1. Oh, we don't have any phase shift. Okay, so we're good to go. So if this is 1, Then we are going to have the asymptotes, stay up here. We're going to have the asymptotes right there because we don't have a phase shift. And the y-axis is also an asymptote. Okay. We're going to go through here and here, the midline being y equals 0. But then instead of just going up 1 for the next point here, I will go 2. So I need to be careful about that amplitude of 2. And we have a reflection. So the cotangent normally comes down, but this one is going to come up, right? So I'm going to come up and be from here and then to here. And that will be 2 of them, so that should be enough. All right, that's it.